Welcome to solverfy.
We are given an integral and a value of n, and in each part we're asked to use a certain rule to approximate this interval with this value of n. The integral is the integral from 0 to 4 of the natural log of 1 plus e to the x, where n is equal to 8. In part A, we're asked to use the trapezoidal rule. So first, for this rule, we want to determine the interval lengths, delta x. These are the rightmost endpoint 4 minus the leftmost endpoint 0 over n, which is 8. So this is 4/8, or in a decimal notation, 0.5. The next step is to find required function values. So in trapezoidal rule, we want to find the values of the function on the endpoints of these subintervals. So I'll make a table. On the left side, we have the endpoints x, and on the right side, we have the value of our function, which is natural log of 1 plus e to the x. So let's start off with our left endpoint 0, and we'll increase by delta x, or 0.5, until we reach 4. So we have 0, 0.5, 1.0, 1.5, and so on. Now, for the right side, all we have to do is simply plug in x from the left side. So for example, plugging in x equals 0, we have the natural log of 2 for our first entry. In decimal notation, this is to 8 decimal places, 0.69314718. Likewise, we plug in x equals 0.5, we get approximately 0.974076. And we continue in this fashion all the way to x equals 3. And so your table of values should look something like this. Depending on how accurate you want to be, you may have more or less decimal places on the right. Now that we have these values, we'll use the formula for the trapezoidal rule for approximation, which we'll call T8 for trapezoidal. We know this has n plus 1, or a total of 9 terms in its sum, and that T8 is equal to, our formula is the interval length delta x over 2 times f of the first point x0, so this is 0, plus 2 times f of x1, plus 2 times f of x2, and we continue in this fashion all the way up to 2 times f of x7, and then plus just 1 times f of x8, which is 3. And then we simply plug in the values for delta x, which is 0.5, and all of our values from the table into the sum, and the answer is approximately 8.804227. to 6 decimal places. And that's the answer for part A. Now in part B, we're asked to use the midpoint rule. This is similar to part A, except for in the midpoint rule, we have the same step size, delta x equals 0.5, but now we want to find the values of the function natural log of 1 plus e to the x at the midpoint of these intervals. So we're going to start drawing another table. First column x, second column is the natural log of 1 plus e to the x. And instead of starting with x equals 0, the left endpoint, we're going to start at the midpoint of the first subinterval 0.5, which is 0.25. Then we're going to add 0.5 until we reach the midpoint of 3.5 4.0, which is 3.75. So we have 0.25 plus 0.5 is 0.75 plus 0.5 is 1.25 plus 0.5 is 1.75, and so on. Then, just as in part A, we're going to plug in the values on the left to get the values on the right. So, for example, plugging in x equals 0.25 into natural log of 1 plus e to the x, this is approximately 0.825939 42, however many decimal places you want. I would suggest at least 6. Likewise, we plug in 0.75, we get 1.136871. And I'll continue this all the way down the table. Table of values should look something like this. And finally, we're going to use the formula. So we know that the midpoint rule, our approximation we'll call M8. We know that this is going to have a total of n, or 8 terms in its sum. And the formula is that M8 is the length of a subinterval, delta x, which is 0.5, times the values of our function at the midpoints of each of these intervals. So we have, from the table above, f of x0 plus f of x1 plus all the way up to f of x7. So we have a total of 8 terms in our sum. And if you plug this into your calculator, this is approximately 8.799212 to 6 decimal places. Finally, in part C, we're asked to use Simpson's rule to approximate the integral, I mean. Now, Simpson's rule is actually pretty similar to the trapezoidal rule, so I'm going to overwrite part A here. So this now becomes part C. Just as in part A and part B, the interval length is 0.5, and also just as in part A, the table is going to consist of, on the left, all the endpoints of the subintervals, and on the right, the value of the functions at those endpoints. So this table is the same as in part A, but now our formula is going to be a little bit different. So below part B here, I'll finish part C. So we know that S8, our approximation using Simpson's rule, has n plus 1 for 9 terms, just like part A had 9 terms. But we know that the form of S8 is going to be the subinterval width, delta x, over 3 now, instead of 2, times f of x0 plus four times the value of f at the next endpoint, x1, plus 2 times the value of f at the next endpoint, f of x2, plus 4 times the value of f at the next endpoint, x3, and we continue in this fashion, alternating between 4 and 2, until we get all the way up to 4 times f of x8, sorry, it should be 4 times f of x7, plus 2 times f of x8, well, that's not right either. 4 times f of x7, since 7's odd, and then just 1 times f of x8, because it's the last term, because it's a total of 9 terms in our sum. And so if we plug this into a calculator, using the values from our first table up here, this is approximately 8.804229. Out to 6 decimal places.